Once again, we've accomplished that first step of getting the first zero in place. Since we don't have any more rows beneath that second row, we're done with getting zeros in place. The next thing we want to do is turn our main diagonal into ones. That means that the negative 12 in this position needs to be a 1, and then the negative 22 in this position needs to be a 1. And we're going to accomplish that by dividing each of those individual values by itself. So I'm going to be dividing the top row by negative 12 and divide the bottom row by negative 22. And so what you see as a result is going to be 1, and then negative 16 divided by negative 12 is what, 4/3. We'll write that as a fraction, 4/3. And 28 over 12, if I divide each by 4, I get 7/3, and that is positive. And the bottom row, 0 and 1. And then 13 divided by 22, I'm not going to round that, I'm just going to keep it as a fraction, just like that. And so now you're done. You can rewrite your matrix as a system of equations. The top equation will say 1 times x plus 4/3 times y is equal to 7/3. The bottom line is no more x's. 1 times y is equal to 13 over 22. Now you can see how convenient this all was, and now worth your time because you know the value of y is equal to 13 over 22. And if y is 13 over 22, I can substitute that back into the line directly above and figure out x. X plus 4/3 times 13 over 22 equals 7/3. And now we're solving for x, right? So let's take 7/3 minus the product of 4/3 times 13 over 22. And make that a fraction. I get 17 over 11. So x is equal to 17 over 11. That should solve your system of equations. Let's continue to example number 8. We're solving this using matrices once again, but we have to make sure that everything is in the correct position. And so you notice on the second equation that minus 4 is not. It needs to be, the equation needs to equal that constant. So I'm going to rewrite this as 9x minus y equals 0. That was okay. But the bottom equation, 3x minus y, needs to equal 4. So that's your system of equations now. We're going to pull off the numbers, off the coefficients and the constant, and we're going to make that into a matrix. The top line of numbers becomes the top row of your matrix. The bottom line of coefficients and numbers becomes the bottom row of your matrix. So the augmented matrix starts out looking like this. Remember, we want to get that 0 in place first. So that's the number we want to turn into a 0. And so I'm going to accomplish that by multiplying the entire bottom row by negative 3 to start. Negative 3 times row 2 is my directions. Top row I'm not going to change, so leave that alone. The bottom row is going to be the result of multiplying everything by negative 3. And this is what you end up with. The next thing you want to do is add those two rows together to achieve the 0 down there in that position. Since the 0 needs to be on that second row of numbers, we're going to write our result all the way across on that second row. Top row does not change. Leave it just how it was. The bottom row is now going to be the sum of the two rows together. So negative 1 plus 3 equals positive 2, and 0 plus negative 12 is still negative 12. Now that you have your 0 in place, you're done with the zeros. You can change your main diagonal now into ones. I'm going to actually go about this a slightly different route this time. Instead of changing into ones, I'm going to take a shortcut and just rewrite each row as its equation. 9x minus 1y equals 0 would be the top line. The bottom line is going to be 2y equals negative 12. Now, you could have gotten ones on the main diagonal, or you could have just left it like this. It's not going to matter, okay? Because nobody's going to know how you got your answer as long as you get the answer. So choose whichever method you like better. The second equation now only has y left. That's because we got that 0 in place. The x component, the x term changed into 0, so it's gone. It's eliminated. So the y is the only resulting variable. And so I'm going to solve now for y on that second line, dividing by a 2. So y is equal to negative 6. So you might go back and ask yourself, well, what if I would have divided by 2 back here? What if I would have gotten my 1 in place there? Well, you're still going to get -6 for your answer for y. So it didn't matter. Now that you've got the value for y, we're going to plug that into the equation directly above in place of the y, and we're going to find x from there. So 9x minus 1 times -6 equals 0. So 9x plus 6 equals 0, right? I just have to solve this for x. 9x equals -6, so x is -2/3. And so there's your solution for the system of equations. You've got x equals -2/3, and you have y equal to -6, and you're done.